Alright, this one I think might be a little more on the newer side. So you've probably talked about it maybe, or at least seen some of these things before, but we're going to go, now the next couple of lessons are going to really go into some of the uses and practicality of exponents. So an exponent, if you have not done it before, it shows how many times a number is used as a factor. So remember, a factor just means that it's a number being multiplied by. And the base is what we use as the factor. So, for instance, I have 5 to the third power is how we read that, or 5 cubed. What that means is 5 is my base, and I'm using it 3 times as a factor. But the way that you write that is 5 times 5 times 5. And again, that little dot means multiplication. We're going to start using that more often as well. But 5 times 5 times 5. And we can actually figure that out and say 25 times 5, which is 125. So that's how we use exponents. The base is the big number, that's the factor, and the exponent shows how many times. It is not 5 times 3. It is 5 to the third power, or 5 times 5 times 5, 3 times. Alright, so let's go into just a few examples of using this. So today's really just an introduction of exponents, and then we'll really go into a little more detail next week. So for instance, if I said write using exponents and find the value. So 7 times 7 times 7 times 7. We have 7 4 times, it's a repeated factor, so we would simply write that as 7 to the 4th. And then we multiply that out. 7 times 7 is 49 times 7. So again, you're going to have to do some multiplication here because this is not going to be just mental math. So that's 343, and then we'd multiply it by 7 again. I believe, now that was fast math, so it might be incorrect, but it should be, I think, approximately 2,401. So go ahead and do 6 times 6 times 6 times 6 times 6. So write that as exponents, and then find the value of it. So writing that as exponents would be 6 to the 5th, and that is equal to 7,776. Alright, now something else you may have heard when referring to exponents is something called squares. A square number is what we're going to talk about next. And this is whenever we use an exponent of 2. So square numbers what we call, what also might be known as perfect squares. Perfect squares the product of a number and itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. Those are the first 10 perfect squares in the number system. So those are just any number multiplied by itself. I could go up to 15 times 15, 100 times 100, 150 times 150. We could go all the way up. But for our purposes, we're just going to deal with some of those first 10 or 12 perfect squares. And so really you could rewrite this then as 1 squared, because it's 1 times 1, 2 squared, because it's 2 times 2, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. So those are the first 10 perfect squares, and that's how you'd write them using exponent form, is 1 to the second power, or 1 with an exponent of 2, which would mean 1 times 1, 2 times 2, 3 times 3, so on and so forth. So that's about all I want to get into today for exponents. This is just kind of a basic introduction to them, and then we will go further into that, and we'll go further into these over the next couple of lessons.